All right, so chapter 3, factors and products. This is a big chapter. There's lots of factoring and multiplication in it. So I'm going to make videos, help you refer back to them. Really important that you are doing the practice work and that whenever possible you are attending class. But at the very least, we've got these videos, so keeping up with them as well. So 3.1 and some of 3.2, I'm combining them a bit. We are looking at prime factorization. So that is a big, scary word. Prime factorization means that you're writing that number as the product of prime factors. So these are prime numbers. So numbers like 2, 3, 5, 7, 11, and 13. Those are our main prime numbers that I'm going to expect that you know are primes. And we are going to be writing a number as multiplying only these numbers together. All right, so let's do some examples here. So there are two main ways we can do this, either a factor tree or a repeated division by prime factors. So you can choose the method that you like in your own work. They both have some pros and cons to them. I have a favorite method, and I'll discuss that later. And you will as well, and it may or may not be mine. So let's keep going though. Prime factorization of 18. So if we have a factor tree, then I put 18 the top in the middle, and I'm going to think of any factors, so they don't have to be prime numbers, which is the bonus of this one. Any factors of 18. Well, 2 and 9 come to mind. Okay, well 2, that's a prime number, so I'm good with 2. But 9, I would need to break down even more, which can break down into 3 and 3. 3 times 3. All right, well 3 is also a prime number, so this would be my prime factorization. So I would write it as 2 times 3 times 3 equals 18. And then because I have 3 times 3, it would end up being 2 times 3 squared is 18. It would be my most correct, fully done solution here. That is the prime factorization of 18. Okay, so that's not crazy, especially with that kind of a small number. But let me show you the repeated division. So for this one, it sets up kind of different. I have 18 still at the top, and then I have kind of like an upside down division sign there. And along sort of this bit here, I'm going to divide by prime numbers. Now I can only divide here by prime numbers. So it may even be helpful that you start making this list of prime numbers at the top of your workstation so you can sort of refer back to them. 18 though, not crazy. I know that 2 can divide into 18 because 18 is even. So 18 divided by 2 will give me 9. And again, I draw that sort of upside down division symbol there. Okay, now I need to divide 3 by a prime number, going back to my prime numbers list. And I think I might have said it there. 9 divided by 3 will give me 3. And I have to divide 3 by a prime number. So when you are doing prime factorization, repeated division by prime numbers, we can only end at 1. So we need 1 in this box. And this is my prime factorization. Again, I have 18 equals 2 times 3 squared. So those are your two methods of prime factorization. It's a fairly small number. We'll get to some bigger ones coming up here next. My favorite method is this one here. It's that repeated division. I find it very clean, right? I'm looking just in one list instead of kind of all over the place as in the factor tree. And it helps me become more familiar with my prime numbers, which is good to have that that awareness of them. But the factor tree can be really good if you're struggling with prime numbers. If you don't see it right away, then the factor tree is certainly a good method to start. And as long as you keep breaking it down fully into prime numbers, you're getting the exact same result. It doesn't matter to me which method you do in your work from now on. All right, we got some bigger numbers here. Write the prime factorization. Then I'm going to ask you about if they are perfect squares, cubes, or neither. And we're talking about that, but squares or cubes. Well, here we go. So 196. Well, 196 is an even number, so I can divide it by 2. Right, so in my calculator probably, 196 divided by 2, that should give me 98. Okay, well 98 is again an even number, so I divide by 2 again, and I get 49. Okay, well 49 is one that rings a bell to me, but I know that is divisible by 7, and 49 divided by 7 is 7. Now I can't stop here. I need to divide by 7 again so that I have 1. And I always need to end with 1. So my prime factorization would be 2 squared times 7 squared. And that will equal 196. Now we can always check our work. Go ahead, put that into your calculator, and you should indeed get 196. So this is my prime factorization. But there is one other question. Is it a perfect square or a perfect cube? Well, you might notice here, right, 2 squared and 7 squared. So those are both squares. So I can take the square root of 2 squared. I'll write that a little different. I can take the square root of 2 squared, and I can take the square root of 7 squared. Right, the square root of 2 squared, that is just 2. And the square root of 7 squared is just 7. And 2 times 7 is 14. So what I've done here is I found out that the square root of 196 is 14. So it is a perfect square. In order to be a perfect square, I need to have even groupings on all of the exponents in my prime factorization. So they don't need to be 2, they could be 4s, they could be 6s, 8s, but I need even exponents on all prime factors. That's how I'm going to get a perfect square. Right. 125. Let's look here now. So I'm going to do my prime factorization again. So 125. Well, that sure sounds like it's divisible by 5 to me. And indeed it is. Divided by 5, that gives me 25. I can divide 25 by 5, and that gives me 5. And remember, I can't stop here. I need to divide 5 by 5 so that I get 1. So 125 is 5 cubed. So this one is a little bit more straightforward. Is it a perfect cube? Oh yeah, 5 cubed. So if I'm taking, call it the cubed root of 5 cubed, that's just 5, right? These cancel, just like we saw that they do for my square roots as well. So 125 is a perfect square. Sorry, not a perfect square, because it doesn't have even, but it has of 3. So it's a perfect cube. And to be a perfect cube, we need exponents on all prime factors. I'm going to say PF, a multiple of 3. So it could be 3, 6, 9, etc., but it needs to be that multiple of 3. Okay, so let's look at a pretty big number. We're going to go through sort of all of those steps. So I'm going to determine the square root of 1296, but using prime factorization and some grouping. So we could, we're not using our calculator, just finding the square root. That's not going to get you very many marks at all for this section. We need to do that prime factorization. So whichever method you like, I'm going to keep doing my repeated division of prime numbers. So 1296, that is an even number, so I can divide it by 2. And that will give me 648. Again, an even number, I divide by 2, and I get 324. Can keep dividing by 2, 162. I like to try to keep dividing by the same prime factor until I can't anymore. And I work from the bottom up. So I start at, is it divisible by 2? Is it divisible by 3? 5, and so forth. And 162 divided by 2 is 81. So I can't divide by 2 anymore, but I can divide by 3. And 81 divided by 3, 27. All right, now I'm dividing by 3 again. That's 9. Keep dividing by 3. And remember, I can only stop when I get my 1 here. So my prime factorization of 1296 is that I have 2, 1, 2, 3, 4 to the power of 4 times 1, 2, 3, 4, 3 to the power of 4. Okay, so that is my prime factorization step. For my grouping now, I'm going to break up my prime factors into even groups. So my 2 to the 4, I'm going to say that's 2 squared times 2 squared. My 3 to the 4, that's 3 squared times 3 squared. And now I can rearrange them. I know, stay with me. So 2 squared times 3 squared times, now this one, 2 squared times 3 squared. All right, so see, these are the same numbers. That is my square root. So 2 squared is 4, and 3 squared is 9. And again, times 4 times 9. So my square root of 1,296 is whatever 4 times 9 is. 4 times 9, 36. So the square root of 1,296 is 36. Write that a little neater. And we can check it in our calculator. But that is indeed my square root. So we go through our prime factorization. That's going to be step 1. Then we split it in 2, step 2, and we work all the way until we're back to some actual numbers. Step 3, and finally, kind of in step 4, we just write our answer. Okay, so that is the main first section. We're going to extend it a little bit further now, though. So the difference between a multiple and a factor. Well, a multiple is going to be getting bigger. This is a bigger number. And a factor is a smaller number. So if I'm talking about 15, if that's my number, multiples are 30, 45, right? Numbers where I go 15 times 2 gives me 30. So I'm multiplying it by 2 to get 30. It's a multiple. A factor, I'm still taking my number 15, but I'm dividing it by a prime factor. Again, that's the key word here. Prime factor, smaller. Divide by 3, 5. So 5 and 3 would be factors of 15. Okay, so in our very last thing that we're going to be doing in this section, let's talk about the greatest common factor. So the greatest common factor is the greatest factor that is common between 2 or more numbers. And we can solve this, find this again, using that prime factorization. So let's find the GCF of 84 and 140 using prime factorization. So I set it up the same, and this is why I really like doing my repeated division by prime numbers. Because if you're doing a factor tree, you have to do a factor tree of 84 and a factor tree of 140, and then combine them. Repeated division, it's really nice. So I'm just going to set up just as before, but I'm going to put both numbers there. 84, 140. Now I need to find a prime number that divides both of them. So they're both even numbers. So 2. 84 divided by 2 is 42. 140 divided by 2 is 70. All right, so again, I have even numbers, so I divide both of them by 2. So I'm getting 21 and 35. All right, so I can't divide them both by 2. I can't divide both of them by 3. Right? It needs to be both of them. But 7 I can, and I'm just going through down that list of prime numbers and trying it out. 7, because 21 divided by 7 is 3, and 35 divided by 7 is 5. Now 3 and 5 have nothing in common, so this is where I stop. So I stop when there are no prime factors left. they have no prime factors in common. Right, and my GCF are these numbers right here. So my GCF is 2 squared times 7. And this one we do typically want the actual number. So 2 squared times 7, that would be 4 times 7, which is 28. So my GCF of 84 and 140 is 28. That's the biggest number that I can divide both of these numbers by. All right, we keep going. Let's look at some more examples. So again, I set them up just beside each other in my upside down division sign. These are also both even numbers, so I divide by 2, and I get 110 and 430. Lining everything up in a nice neat line. Again, I can divide by 2, and I get 55 and 215. Okay, well, both of these numbers end with a 5, so I divide by 5, and I get 11 and 43, and now there's nothing left in common, so I'm done. My GCF is right along here. GCF is 2 squared times 5, which is 4 times 5, or just 20. So that would be my greatest common factor of 220 and 860. Okay, so this one here looks a little different, but it's the exact same thing. So notice these are the same numbers, 220 and 860. I just also have these variables here. That doesn't change anything, right? It doesn't matter what these things are. I have x squared and y xy squared. So I'm just going to do my variables at the moment because I already have the GCF of the numbers. What is common in these two terms? Well, they both have an x. So I'm going to divide by x. And this one is left with 1x, y, and this one is left with y squared. Okay, and what else they have in common? Well, they both have at least one y, so I divide by y, and I get x comma y. Now there is nothing common between x and y, so I am done. My GCF of those variables is xy. My GCF of these numbers, we found that before, that's 20. So if we combine that together, the GCF of 220 x squared y and 860 xy squared is my number 20, and these guys 20xy. So whether I'm dealing with actual numbers or numbers and variables or just variables, it's the same process. So don't let these x's and y's scare you. It's the exact same thing. And we just multiply them together at the end, so it looks like that. 20xy would be our GCF. Okay, so now the last thing I want to do, and it is a bit of an extension of the accumulation of what we've been doing today, is to factor the polynomial above, so this one, by removing the GCF. I should have written it again, but I'll write it here, and you should write it as well. So 220 x squared y plus 860 xy squared. So that should have been in your notebook. So that's a polynomial. It has two terms, right? This is one term, this is a second term. And I want to factor it by removing the GCF. So what that means is I'm going to take my GCF I found here, my 20xy, and I'm going to divide both of them by 20xy. Well, 220 divided by 20 is going to give me 11. X squared divided by x, all one of these cancel, and I'm left with x, and y divided by y, that cancels out completely. And now I am going to look at my 860. So 860 divided by 20 will give me 43. And my variables, so x and x cancel, and y squared divided by y, one of them cancels. So that's 43y. So that's me removing the GCF. But if I'm factoring it, this doesn't disappear. So 20xy, the GCF goes on the outside of it. Now I know this is a big step here, this one. I divide all terms by my GCF, by that one term that I find that is common in both of them. And I pull that out to the front. It doesn't disappear. Right? Factoring, it's important that I'm able to get back to my original equation. So it doesn't disappear, but it goes out to the front, and then in brackets, everything else that has been divided by that GCF. All right, so that's our quick run through prime factorization and GCF. We've got practice questions, which I cannot emphasize enough how important they are that you are doing, completing and asking questions if you're unsure, because this stuff is going to build the foundation of everything else that we're doing in this chapter. So it's really important that you are strong and confident with it. So asking questions, doing the work, that's the way to get better. All right, and I'll see you in class. So ask me your questions.